All right, here we go. Welcome back. What we're gonna do now is like you just went over the whole thing about concentration. Do you get it? It's basically solute to solvent. Tells us how much is actually in the solution. We've got three kinds just to review. You've got molarity. That's moles per liter. We've got percent composition by mass and by volume, and we have parts per million, which is basically percent composition only multiplied by a million instead of 100. So let's just dig into it with these, man. Let's just get these going. So here's the first one. The first one is saying find the molarity of 100 mils. Do you see that? Do you see that right there? See how we're starting out with milliliters, and you know that that's wrong, but you know that you're also just gonna go one, two, like I'm sorry, you're gonna go 1, 2, 3. Okay, so it's zero point 0.1 liters. Easy. I'm gonna start over now. Find the molarity of 100 mils of a solution that contains 2.5 moles of solute. Okay, remember I told you before that it's all in your reference chart? Watch this magic. I'm going to come over here, going to bip the boop. Oh, look at that. You like that? This is your handy dandy reference table. I just Googled New York State chemistry reference tables. That popped right up in the like googly thing. So way down here, I'm going to come down here. Oh, look at table G. It's a friendly little friend there. We're coming on down. You gotta love April pressure. I know you do. Came down here. Went down here. Okay, oh, this is sideways, so I just rotated view so it would be like this way instead of this way. We all love table S, and there it is. There's the back of your reference table, and right here is where all your concentration stuff is. Parts per million, molarity, and percent composition has its own thing. So it's like part of a whole, whether it's grams or volumes or whatever. Got it? Good? All right, let's go back. So find the molarity of a solution that contains 0.25 moles of solute. I'm going to come back here. Right there is my molarity concentration or equation. So in this case, the molarity is going to be our x, right? And what we need to find is, all right, we're given that it's 0.25 moles, right? And again, they're going to mess with you by giving you milliliters, but you're smarter than that. So you're going to take the decimal place. You're going to start here and go, you're going to go 1, 2, 3, and you're going to use 0.01 liters. So it'll be 0.25 moles divided by 0.1 liters. Hold on a second. I can't. I'm not going to do that. 0.25 divided by 0.1. Is that what you guys got? Because I know you're all doing it with your calculator too, right? I should be able to do that math in my head. I really should, but I can't. So that's it. That's all there is to it. 2.5 capital M for molarity. That's our concentration moles per liter. That's simple, right? So you see the math itself is not very hard. The tricky part is knowing what goes where. And I'm telling you, what will really help you is to have this with you. This like, is it there? I can never get the pointy thing right. Who cares? Having this with you right in front of you is going to be a really big help because if it's a molarity question, right there it is, right? There's really there's no guessing. You just have to be really careful that you put the right numbers in the right place. So you have the right variables. Got it? Sweet. Next, here, what is the molarity? Right. You see how that works? So here's my equation. Molarity is moles per liter of 250 milliliters. Again, milliliters instead of liters, but we ain't scared. Of a solution that contains 40 grams of dissolved sodium hydroxide. Okay, now they're being mean because we know it has to be moles per liter. Ugh. All right, so Ooh, I don't like that. That doesn't look fancy enough. Let's do this. No, do that. There you go. So molarity, capital M, this is going to equal, it has to be moles, but this is grams. So what's happened? All right, so here's what we're going to do. We're going to convert grams to moles, okay? So we have 4.0 grams, right? And we are going to divide this by the gram formula mass. here's a little trick too. See how you have grams and you want to go to moles? I didn't tell you this yet. So we're going to come over here. Look, again, everything you need will be here, guaranteed. It's right here. See this equation? Number of moles, given mass, gram formula mass, right? Does that make sense? So this is the mass. You divide it by the gram formula mass, you get moles. So that's you don't even need to use the. Well, I guess my point is you don't need to use the lines of pain anymore. It's right there in your reference chart. It's been there the whole time. You didn't have to use the lines of pain, but you did. Yeah. So if they give you grams and you need to convert it to moles, you may use lines of pain if you are a boss enough to be able to do that. But if you feel free to use this right here, this equation right here. Got it? So number of moles is mass divided by the gram formula mass. Well, you might be asking yourself, what is the gram formula mass of sodium hydroxide? I don't know. That's why I have this thing, and that's why I came up here and made this like horizontally. So handy dandy thinky brain part. It's going to be sodium hydroxide. Sodium hydroxide, NaOH. Sodium is right here. It's going to be about 23. Hydroxide is an oxygen, 16. And then a hydrogen, oh yeah, it's going to be just about 40 grams. 40 grams per mole to be exact. So it'll be 4 divided by 40. I can do that in my head. I just didn't want to. I just didn't want to. Stop judging. All right, anyway, so we're going to come back down here. So now that we converted grams to moles, we have 0.1 moles, right? We're not going to be fooled by that gram thing. The equation is right on your reference table, so we're not even going to stress it anymore. And it's going to be 0.1, because that's your moles. And you're going to divide it by not 250, because remember, we're smarter than that. We're going to go 1, 2, 3, and we're going to use 0.25. Going to go back to our brain. How cute that little puppy is. So cute that. Oh my God, I can't even take it. We're going to go back to our little thinky brain part and do 0.1 divided by 0.25. Wait. It's amazing, isn't it? You guys are like chemists. You're doing chemistry stuff. It's amazing. All right. Next. Now this time instead of asking for molarity, they're asking for moles. So it's not going to be x equals. It's going to be something equals x over blah blah. Actually, I guess I should read it first before I start talking. Yeah. All right. So how many moles of solute are dissolved in 3 milliliters of a of a 2 molar solution? Okay. So again, the equation is molarity. This is my molarity, right? So it'll be this is going to be 2.0. Again, not Viking-y enough. There, that's like Viking-y and stuff. So 2.0 my molarity is going to equal moles divided by liters, right? And they gave us liters. It's like right there, only, again, they're messing with us by giving us milliliters instead of liters. Still not scared. You dig? Yeah. You guys see how this is going, don't you? Don't you? 2 times 0.03. Right, 0.06. Don't judge, I'm not. Shut up. Go do something else. Yeah. And I should do this for a living. Or something. There. Complicated? I hope not. Ooh, oh, all right, the next one. I have a feeling we're going to be moving away. Oh, look, okay. No. Okay, how many grams of silver nitrate are needed to prepare a 200 ml solution of 0.1 molar? A solution. See, see, they're not being nice. Again, don't hate the player, hate the game. These are all straight from Regents exams, and in this case, they're asking for grams. This is silly. The grams, it's silly because look. in your molarity equation, do you see any grams in here anywhere? No, not any gram, but you do see this. You do see moles, right? And we know how to go from moles to grams, right? Because we have this right there, right? So if you have grams and you have the gram formula mass, you can do moles. Easy. Okay, so how many grams of sodium nitrate you need to prepare? Okay, we're going to do this one. This is going to be super easy. Don't even bother with me. So 0.1. Again, this is not a, what are you doing? 0.1, that is my molarity. It is equal to moles divided by liters. We're just going to do it without even thinking about it, right? We're not even thinking about it. And that's going to be equal to oops. Right? You get it? Okay. So now that I have 0.02 moles of my stuff, where does that 0.02 moles go? It'll be 0.02 will be equal to my grams divided by the gram formula mass. And look, I have the gram formula mass right there. Okay, so it's going to be moles is moles. What is my number of moles is going to be equal to grams divided by my gram formula mass, which I so kindly, I've already done that for you. You dig? Probably gonna have to. Yeah, so it's gonna end up being, let's do this. So it's gonna end up looking like this. Grams is going to equal does that make sense to you guys? So I'm gonna take out my brain. Uh, 3.4-ish grams after we like round. How's that sound? Easy enough? I think it's pretty easy. All right, what percent by mass? What percent by mass of a solution containing 3 grams of ethanol is dissolved in 3 grams of water? Man, percent. The percent is, the percent is equal to part over whole. So in this case, the part is 2.3 divided by, what is the mass of the whole thing? Well, if we have this much ethanol and this much water, the whole thing is not going to be 10. It's going to be 12.3. You see how I did that? But don't forget, times 100. So, not having enough of a brain to do this myself, about 18.7. Make sure you guys get about the same result. Does this make sense? Part over whole. The whole thing, both parts. Does this make sense? Because 3 grams was dissolved into 10 grams. So you gotta add the two. You gotta add the two together. Percent by volume. It's gonna be the same thing. With percent of dissolved, 18 minutes of glycerin dissolved. Okay, same thing. In this case, the percent, because I can type, the percent is equal to, so remember, we're going to have to add these two things together here, okay? So what is 18.2? Oops. All right, so it'll be 18.2 divided by 103.2 times. You guys get the math? So do that yourself. Write the answer in the comment in like in the classroom. Do that. Now this one, about 0.0035 grams of hydrogen sulfide are dissolved in 10 grams of water. Express this in parts per million. Part over whole times a million. Put the answer in the class comments. You guys take care of yourselves.